All right, so we are going to pick up where we left off yesterday. So we are on the last section of the notes in that notes packet I gave you. So we went through and we came up with, we used sum and difference identities to come up with the double angle identities, okay, listed here in the box. And there was 3 versions of the cosine double angle. So we did, for the first example, we had to sketch an image of angle A and use the fact that they gave us cosines ratio so that we could get sine and tangent of that angle to use in a couple of the problems. Is everybody good with this one? Okay. So then we're going to flip over to the back. Okay, so in this example, or these several examples, I guess I should say, parts of this example, you'll notice that it doesn't match exactly when you look at some of these. They don't match exactly what the double angle identity looks like, but they're really close, right? Like 10 sine x cosine x isn't an identity, but what is an identity that looks really close to this? 2 sine x cosine x. Is there a way that I could rewrite this so that I do have that identity? 2 is a factor of 10, isn't it? So I could write it as 5 times 2 instead of as 10. Okay, so I'm going to do that. Now that right there, that's your which double angle identity? Is that sine, cosine, or tangent? That's sine, and then x is the angle here. So since this is the double angle, this is sine of 2x. And then I've still got the 5 in front. Okay, so we're just using double angle formulas to rewrite the expressions in a different form. So that is that. Okay, so for B, this looks similar to the format of one of the double angle identities. Which one does it look similar to? The cosine. But what is the cosine identity? 2, or hang on. 1 minus 2. I started to write 2 minus 1, sorry. 1 minus 2 sine squared. Is there something I could factor out of this expression to be left with this? The 7. Okay, so if I factor out the 7, now I'm left with this, which is one of the versions of the cosine double angle identity. So I could rewrite that as cosine of 2x, and then I've still got the 7 in front. Okay, so you can factor values out. You can rewrite terms as their factors to be able to get the identity that we need to substitute. Okay, so in C, this one is a little different. So I'm going to introduce something here that you're going to use a lot in calculus. It'll become common practice. It's called U substitution. Okay, so when there's a value, in this case 3x, that you don't know what it is, but if it was just a single variable, you would be able to work with the expression. You can just replace whatever the expression is with U, substitute it, and then at the end, substitute the true value back in. Okay, so what I'm saying is I'm going to say U is the same as 3x. So I'm going to replace 3x in this expression with a U. Bless you. Now that's going to be a lot easier to work with, right? When it's just a single variable for the angle. Do y'all agree? So now this mimics, it's really close to what identity? the sine double angle again, except it shouldn't be 16. What should it be here? A 2. So how can I break this down? 8 times 2 sine u cosine u. Then I can replace that 2 sine u cosine u with sine of 2u. And I still have the 8 in front. Now I'm not quite done because I have to substitute the actual value 3x back in for the u now that I've done my simplifying. So what is 2 times 3x? So this is going to become 6x. This is called u substitution. Okay, so we're going to try u substitution in D as well. So what should we say u is equivalent to? Okay, so we're going to replace the 6x terms with u. And so that would be written as cosine squared of u minus sine squared of u. And what identity is that? That's one of the versions of the cosine double angle, right? So I could rewrite that as cosine not squared, excuse me. Cosine of 2u. And now I have to substitute the 6x back in for u. And what's that going to come out to? 12x. All right, so I'm going to give you all a second. I want you to try E. Use U substitution and give that one a shot. So that one's going to kind of combine what we did in these previous ones. You have to use U substitution and you have to factor. No, on Monday. Next week. Oh, a quiz? We're testing next week on Wednesday.
Oh, it's no quiz. Just when you come out with.
Yeah, I'm going to talk about it when we finish the notes. Okay, I'm going to unfreeze the screen. Y'all can check. Okay, so U substitution, we used U as 4x. So we replaced the 4x and then we could factor out a 3, leaving us with 2 cosine squared U minus 1, which is one of the cosine double angles. So cosine 2U. And then I substitute the 4x back in for U, which comes out to 8x there. I feel okay about those types of questions? All right. Now, a little more complicated sometimes is actually solving. Now, actually, I'll talk about it right now. The other pre-cal teachers and I met, and we decided that when we test Wednesday, we're not going to test over all of this notes packet all at once and using them solving. We're going to break it up into 2 tests. So Wednesday's test for next week is only going to use Pythagorean, reciprocal, quotient, cofunction, and odd even. So this double angle that we're just learning now, we're not going to test over that next week. It'll be a week later than that. So we'll have some more time to practice this and work with this since they're a little more complicated. And then on the first part of the test, so the test Wednesday, will be simplifying and verifying, like that proving the left is equal to the right, or just simplifying. There will be some solving equations, but they won't use the identities. It'll be like it'll be a review, like a spiral of what we did before break, the first part of Unit 4 that we already tested on. So it'll be solving trig functions where you may have to do like factoring or whatever, and then you split and solve and you're using your unit circle values, but it won't mix the identities in those together yet. So then when we do the second part of the test, we'll incorporate the rest of the identities that we are learning, and we'll do the more complex solving with the identities, okay, to give y'all a little more time to get used to those, and we'll be able to do a little bit more practice first. Okay, so this type of example this whole part is not going to be on the test, this set of notes. So if this, because I think what we've done so far in the packet, this is going to be the toughest, we'll still have another week to practice and ask questions and review this. Okay, so don't get too worried or worked up about testing on this part next week, because it won't be on next week's test. All right, so we're combining the use of the identities, the double angle identities, and solving. So it's mixing what we did before the break and what we've just learned. Okay, so I see here sine of 2x. So I'm going to use its double angle identity, which becomes 2 sine x cosine x to make, so this is the substitution I'm making. I'm replacing this with this. And I've still got the plus cosine x equal to 0. So then I see that I can factor. Hopefully you see that both terms have a greatest common factor of cosine of x. So when I factor that out, I'm left with 2 sine of x plus 1. So when I get to this point, each of my terms, each of my factors has only one trig function in it. So I'm ready to split and solve each of those individually. So remember, this is what we did last semester at the when we did the first part of this unit. You set each factor individually equal to 0. And solve them. So this one's already isolated the cosine x, so there's no solving needed. We just need to answer when is cosine 0, at what angle. So it's just remembering your unit circle values. So where's cosine 0? Okay, let's work. We're going to work in radians because it says between 0 and 2 pi. Okay, so pi halves and 3 pi halves. Good. So we've got 2 solutions from that factor. Okay, and then over here to isolate sine of x, we would have to subtract the 1 and then divide by the 2. So where is sine negative? First of all, what quadrant is sine negative in? 3 and 4. Remember, all students take calculus is where those trig functions are positive. So sine's positive in 1 and 2, negative in 3 and 4. So from quadrants 3 and 4, what's the reference angle where sine is 1/2? Sine is 1/2 at your pi 6th reference angle, right? So the pi 6th angle from 3 and 4. No, hang on. Yeah, I started to write what y'all are saying. I wasn't even proofing you. Okay. 7 pi 6, that's the quadrant 3 angle with a pi 6th reference, and 11 pi 6ths. You remember doing this in December? Okay, so we used the identities and did what we did in December. Okay, so on number, or I'm going to skip B for now. I'm going to go down to C. Go ahead and answer this one. I'm going to replace the cosine 2x. I'm going to use the cosine double angle. You've got 3 options. There's 3 cosine double angle formulas. So look at what the rest of your equation is and try to decide when you substitute that with the identity, which one's going to benefit you, make it easier to solve. Which one should I replace this with? I'm going to replace this. The other term here is a cosine term. So what should I replace this with? If I replace it with the one that only has a cosine term, I'm going to be able to factor, right? Okay, so that's what I'm going to replace it with. So I'm going to replace it with the 2 cosine squared x minus 1. So I make that substitution first. Now, when I look at this now, I've got a cosine squared, a cosine, and a constant. I've got a trinomial, right? A quadratic form trinomial. So I'm gonna rearrange this and write it the way that we would normally see it. So we have the cosine squared term first, and then the cosine term, and then the minus 1. So now this is quadratic form trinomial factoring. You have to remember your factoring skills. So 2 cosine squared of x is only going to have 2 factors. 2 cosine x and 1 cosine x, right? 1 is only going to have 2 factors. 1 times 1, right? I guess it's really only 1 factor, but repeated. Notice it's a minus 1, so these have to be opposite signs, don't they? Okay. We want the middle term to add to a positive cosine x. So which of these do I want the minus on? The inner one, right? Because remember, you do inner and outer. And so the 2 gets multiplied by the outer. That's what we want to be the positive. So we have 2 and then minus 1 gives us that positive 1 in the middle. Now we're ready to split and solve. So if I have this set equal to 0, I would have to add the 1 and divide by the 2. So I end up with cosine x is 1/2. And over here, I would have to subtract the 1. So I end up with cosine x equals -1. Okay, so where's cosine? -1 in radians. At pi. Where's cosine positive 1/2? Pi thirds. And what other quadrant is cosine positive? Quadrant 4. And so that's the 5 pi thirds. Is this making sense? Okay, so it's kind of just putting things together that we are learning now and we learned last semester. For this one? Because if I set this, I skipped the step of setting it equal to 0, but if it's set equal to 0, I'd have to add the 1 over to the other side. So it becomes positive. Mm-hmm. All right, go ahead and give D a shot. I'll give you all a minute. I'm going to freeze the screen and y'all try D. Don't think you've got it? Need more time, or you think you've done? A few more seconds? Okay. So here, the substitution that I would make, again, it's the cosine double angle, but the other term is sine this time. So I would replace it with the cosine double angle that uses sine only. So 1 minus 2 sine squared x. When I do that, I have a trinomial again. So you may have done this in an additional step or all at once with me, but I don't like my lead term to be negative. So I divided out a negative, so it changed the sign of everything. So I ended up with 2 sine squared x, that became minus sine x, and that became minus 1. Okay, and then I factored, and then I split and solved. Feel okay with that one? I just divided everything by a -1, and when you do that, the 0 doesn't change because 0 divided by anything is still 0. So if you want to change the sign of one of your terms, you just change the sign of all of your terms. You can do that. Good? All right, now I'm going to go back up to B. And actually, I'm not. We'll come back to B after we test because I don't want to confuse you. It's not even on this test coming up. So we'll come back to B later. We don't need it today. And then I'm going to hang off on the half angle because that's not going to be on this first test. We'll come back to the rest of this later. All right. So you have your Alex that was due last night. I'm actually putting those grades in. So don't forget, if you didn't do that, go back and get that completed for a late grade. And then I've gone ahead and activated an Alex review assignment. It's not for a grade. We don't take the reviews for a grade. But I'm going to pass out a paper practice for y'all to do. So the new Alex review is not a grade. That's just review. And you're going to have time to work on that next week before the test as well. But if you want to get a head start this weekend, you can. But this is the assignment for today, this paper that I'm going to pass out. It's a circuit. So the way a circuit works, if you have not done one before, let me pull it up here real fast and I will show you. So there are the problems listed, and then above each problem in the square, there's an answer. That is not the answer to this problem. It's an answer to one of the problems on the page somewhere. So notice none of them are numbered except for number 1. So you work this problem, you get an answer, and then you find that answer somewhere on the page. Okay, so let's pretend this was the answer. Then I would do this one next. This becomes number 2. And I work that and I get an answer. And then I find that answer and that problem becomes number 3. Does that make sense? So you have an answer bank. All of the answers are on the page somewhere. So if your answer is nowhere to be found, you either haven't gone far enough in your simplifying, or maybe you've gone too far or made a mistake somewhere. Okay, so it's like a way to self-check as you go. And then whenever you get to the last problem, the answer you get should be this, negative cosecant theta. That should be the last answer for the last problem you do. And because it takes you back to number 1. Good? Okay, let me pass that out. I'm recording right now, so let me stop this recording first.